First of all, I would like to thank you for coming, and I should apologize that I have a cough, but I have been given a eucalyptus cough sweet of such horrible taste that I hope it will cure me without having to take it. But this is the title of my lecture, and it's a tribute to Ronald Nyholm, who I believe is probably, or was, the most distinguished inorganic chemist that has worked in the UK in my lifetime. And so here's a picture of the medal, and you will see it is the Medal for Education, and I'm really quite frightened. I have no qualifications in education whatsoever, apart from my undergraduate degree, and so I've never given an education lecture before, and I'm rather frightened after we've heard these experts talking before tea. So you will have to forgive me if I talk rubbish about education. And I thought I would begin at the start of my teaching career, which is here. It's a so-called 88 set military radio, and it was these were state-of-the-art in the late 1940s. And at the age of 15, I suddenly found myself from one week to the next becoming Lance Corporal Poliakoff and having to teach my classmates how to use an 88 radio. This is the radio, this is the battery. You wore them on either side of your belt, and you had headphones, and it's what's called a simplex radio. You can either listen or you can speak, but not both. And so you have a thing here that you squeeze. So you squeeze and you say your message and then say over, and then you listen. And this is for the officer to listen. There's also an aerial that's not shown, and the aerial's collapsible like this, because obviously if you're in a foxhole, you don't want this sticking out saying, shoot me here. And so you may ask, what is there to teach about a radio except squeezing it on and off? And the answer is that everybody in the army has to speak the same way, or else your unit can be identified. And in the book, it said, the handbook, that there was some German radio operator who used to say plonk in every message, and his unit was tracked from Russia to the D-Day beaches just by listening to him. And so there was I, little boy, trying to teach my colleagues how to use radio, and that's where I started teaching. And the only other training I had in teaching is that I read a book, which is this one, which is really very good, Teaching as a Subversive Activity. And the main message of this book was that on the mirror in your bathroom, you should stick up a notice saying, what am I going to teach today, and why am I going to teach it? Which I think is quite a good idea. And it had two quite nice concepts, or things that teachers and students should avoid. And for the teachers, they said, most exam questions are guess what I'm thinking questions. And the students may not necessarily guess what the examiner wants. And they said most students use the measles theory of education. That is, if you catch something once, you'll never catch it again. And so this is particularly bad, actually, in modular teaching. And so you can still buy this from Amazon, second-hand, £4.81 plus postage. So I would recommend it to you if you want to learn about teaching. There are two people that have really been very influential in my teaching. There is Alec Campbell, who was died. They both died, actually, in 1999. Alec Campbell, who was a technician at Newcastle University, where I worked, and became a lecturer. And he taught the entire foundation year in chemistry. He taught inorganic, organic, and physical, and demonstrated all the lab classes. And he was a fantastic person for me to learn from some of the basics about teaching. And the other person is our own Colonel B.D. Shaw, who used to lecture in this lecture theatre, fortunately before the carpet was put down, or there would have been safety issues. And he taught me quite a lot about doing lecture demonstrations. And B.D. Shaw, sadly, is no longer with us, but when you go out for the wine, look at those bushes under the silver birch trees outside, and B.D. Shaw's ashes are fertilizing these bushes. So he is still with us in spirit, or at least chemicals. So this is my first chemistry book, inorganic chemistry. And what is interesting from my point of view about this as an inorganic chemist is that it doesn't have a periodic table in it, which is extraordinary because the periodic table was invented by Mendeleev for teaching inorganic chemistry. And here, a book published 92 years after Mendeleev doesn't have it. But I had a periodic table. This is my first periodic table. I've got it here. You can see it's not very big. This used to hang beside my bed. How many of you here have got periodic tables in your bedroom? Oh, quite a few. And I actually, when I was at school, I had two. I had this one, which is quite small, and a big one that like you have in a classroom that was the same. And if you look at this, it's much the same as now. Argon is A rather than AR. But what is quite interesting is that the groups are labeled from 1 to 7A, and then 7B, and then along here, 1B, and so on. And this gave rise to really stupid questions in exams, such as, compare the chemistry of manganese, which is in 7A, with chlorine, which is in 7B. And it's not obvious that manganese and chlorine should have similarities in chemistry, though for those of you who are chemists, it does form MO4 minus, both of them form MO4 minus ions, and so on. But fortunately, it's been renumbered so that there isn't such rubbish nowadays. But if you want to know more about these, we uploaded a video about the book and the periodic table, which have been watched by 5,300 people, perhaps some of you since then. So I then came to Newcastle in 1979, and my first new lecture course, because the first bit of teaching I did, I was given somebody else's notes and told, it's not an important course, use these, don't rewrite them. But my first new course was about the chemistry of the main group elements from nitrogen to xenon. For those of you who can't remember, nitrogen is there, xenon there. It was actually originally from oxygen to xenon, but one of my colleagues disgraced himself and was so slow talking about the carbon group that one year the whole of the nitrogen group was left out. That his lectures were running 4 hours behind where they should have been. And so a whole year, you should not minute this, but a whole year of Nottingham graduates went out without ever having a lecture on the group 15, the nitrogen group. And so I was given that as well. And Ron Nyholm was a specialist, or one of his areas of chemistry was arsenic chemistry. So I thought, just to give you a flavor of my lectures, I would tell you a little bit about arsenic. And this is one of my slides. It wasn't very good, which shows arsenic, antimony, and bismuth. You can see they're all metals. And I pointed out, which many of you may know, that Professor Challenger, who was a PhD student here in 1908, ended his days living in 19 Elm Avenue, Beeston. The house, this is the house, it's been slightly extended since he lived there. And he was really famous for discovering the chemistry about how molds on people's wallpaper and things like that converted arsenic into volatile compounds that poisoned generations of Victorians who had mouldy wallpaper. And so I then mentioned to the students about the question, was Napoleon poisoned by his wallpaper? For those of you, the younger ones, because you don't learn history anymore, Napoleon, when he was defeated, was sent to a very damp island, St. Helena, in the middle of the Atlantic. And this question was examined by my friend David Jones, who's in Newcastle. And this is Napoleon's sitting room in St. Helena with the original wallpaper. And David managed to get a sample of one of these circles. And so here it is, and he showed that this green stuff on there was actually a copper arsenic compound called Scheele's green, which did contain arsenic, and there was enough arsenic in the wallpaper to explain why Napoleon's hair has arsenic in it, but there wasn't enough to have killed him. And quite amusingly, an Australian chemist called Bruce Wilde used the same chemistry quite recently for coordination chemistry, inorganic chemistry. And he did a truly mad experiment, or rather his lab assistant did. So this is the paper, if you're interested, with Bruce Wilde, published in 1990 in ChemCom. I should say that my colleague Steve Howdell found this paper. I just had the photos. And Wilde persuaded his lab technician here, called Paul Gugger, to bake some bread in the lab containing arsenic. Very fortunately, I have just stopped being inorganic safety officer, so I don't have to talk to you about how you would do a safety assessment of baking bread containing arsenic. But what he did was they put this compound here in the bread, and then they put mold on the bread, so it produced this arsine compound by the mold reacting with it. And for those of you who are chemists, arsenic compounds, although they're pyramidal, have a very slow rate of inversion, so you can get optically active arsines. So what they did was, and this is quite a clever piece of chemistry, they put the mouldy bread in here and let this volatile arsenic compound go up here through the tube and into this thing that contained a salt of platinum. And so after they waited a few days, they isolated from this platinum compounds with optically active arsenic ligands. And it shows to you how 19th century chemistry can be used in modern chemistry. I think it's a completely bonkers experiment, but it's quite fun. So now I want to talk to you about a life-changing event for me. And I should explain to you, especially those who are younger, that life-changing events usually don't appear that they're going to be life-changing before they happen. They often can seem quite boring. And in my case, the life-changing event was the EPSRC university visit on 11th of April 2008. The EPSRC is the Engineering and Physical Sciences Research Council that fund most of the research in chemistry at universities and in the other physical sciences. So there I was, like most of my other colleagues, getting really excited. I was going to go to this and try and get the magic formula so I could get a really big grant in my next proposal. But just before I went, the day before, I got an email from the senior management at the university asking me to go to a fringe event. And being obedient, I registered and got this reply saying, "Thank you for registering for the corporate communication workshop," which you must admit does not sound very exciting. And so I went to this, which is in quite a small room in the Trent building. And at this meeting, Jonathan Ray, who was at that time the director of communications at the university, unveiled or described the university's YouTube channel, being a professor, I'd never heard of YouTube. And their channel was called TestTube, and the university had collaborated with a video journalist, Brady Harron, and had produced videos about science. Here is David, I've forgotten his surname, from Life Sciences, reading a letter out saying that, very sadly, he has not got a grant from the proposal that he had written. And you can see he looks suitably cheerful, maintaining the stiff upper lip tradition of our university. And I got really excited by these videos, and I went back to my office and sent this email to Jonathan Ray and to Chris Rudd, who's PVC, who's I'm delighted to see in the audience, saying, "Dear Jonathan, I'm really impressed by TestTube. I've spent most of the afternoon telling my colleagues and students about it. Well done, Martyn." Now, you can imagine that an enthusiastic email like this immediately resulted in an invitation, "Wouldn't you like to make a video?" So Brady came to video me. In a really bad day, I had been teaching from morning till mid-afternoon, and I was feeling really tired, but I did it. And the result was 7 videos, which, because my brother, or some of you may know, my brother is a film director, Brady made on YouTube into the Poliakoff boxed set, just to show that I could do it as well as Stephen. And so I will show you, only one of these videos is about teaching, so I will show you the one that's about teaching. Well, I do quite a lot of teaching to the first year students, and I use dog toys to film, to demonstrate them. It looks like a molecular model, but it's actually called a wiggly giggly. It actually looks just like a molecule, the shape of a molecule of methane. So I could not resist bringing these, you can see. So if you wish to come and play with them afterwards, they're still here. Now, Brady and I got on very well together. His theory is that we wished we were doing each other's jobs. He would like to be a chemistry professor, and I'd really like to be making videos. My theory is that we're both obsessive workaholics, and therefore we share our addiction together. Anyway, the upshot was that we got on very well together. This is Brady here. Perhaps you should wave your hand, Brady, wherever you are, so that, because you can't be seen very well here. And I won't point the laser at you. And a few weeks later, Brady came with the idea of making a periodic table of videos. And his idea was that you would have one video about each element. And I told him he was mad, because how could you talk about some of these elements, like this one here, element 117, where no atoms have been observed by anybody, at least at that time. And after some argument, he said, he persuaded me. And so I managed to get some money from a grant that I had, plus some money from the School of Chemistry here from our colleague Mike Healy, and we decided to make the videos. So the idea is that you click on something like hydrogen, and there's a video about that. And I should say that Brady hates this video that I'm about to show you. I like it because it's our original trailer, and I think it has historical interest. But this was what we managed to do in a period of 5 weeks.
So this sample, it's a very, very interesting sample. It's arsenic.
And I should also acknowledge my colleague Pete Licence, who starred in this. You should wave your arm as well, Pete, for this. So we started filming on the 9th of June, and we finished the website on the 17th of July, late at night, or it may have been early in the morning. This was dictated partly by the money being about to run out or be repossessed by the university, and partly because Brady was going on holiday, and we had 120 videos. There are only 118 elements, but there was that trailer and an introduction. And the total running time was 4 hours and 7 minutes, which is 2 Harry Potter films or 3 arty French films. So it's quite, so it's really quite long. And this was done a year ago, was the number of hits of the different elements. Red means it's more than 200,000 hits, and now it's probably 300,000 hits, and even pale blue is more than 10,000 hits. And what's really surprising is for example, the video here of the element francium, which is so radioactive that there are only a few atoms at any time in the world, that so many people have watched this video, which was little more than me pointing at my tie with the various elements on it. And and we got all sorts of comments. First of all, these are some of the countries, not all the countries. I've picked out the countries in Africa because I was giving the lecture recently in Africa, and you can see there are a huge number of countries where this has been watched. And it's even been watched in Afghanistan, though I suspect these are the American troops rather than the Taliban. And and we've had lots of comments for every video. These are some early comments. Awesome vids. I wish I'd found them before I did my science GCSE exam. You can't tell whether that's somebody who's just done the exam or some middle-aged man who is ruining his misspent youth. But I love your videos. Just watching these videos, I've learnt more than a full term at college. And and videos like these is what makes me interested in school and better improving myself. Thank you. Then, as well as that, some people have posted their own videos in reply. This guy at the time, that's here and here, was a Finnish 18-year-old. I don't know who this is, who had enough cesium to let it off in their bathroom or kitchen. And this is a slightly mad person who made videos with a rubber glove wearing a pair of safety glasses. And then there was a lot of press coverage. The Daily Mail, perhaps this is not something one should be proud of. A leading Russian business magazine, and this one here, which was in Hebrew, which I don't understand, and it took me a long time to get it translated. But the key phrase here says, looks as if he went into the barber and said, give me an Einstein, but make it wild. And but we got lots of comments like this. I don't care what they do as long as they keep on making videos. And so we suddenly found what had been really a quick experiment had become an ongoing project. And so I'll now try and explain to you how we have been taking things forward and the sort of things that we've been doing. And one of the things we've been doing is trying to build up the number of subscribers that you have on YouTube. And so we did all sorts of extras. If you remember, 2008 was the year of the Olympics. So there was an Olympic video on gold, silver, and bronze. For those of you who are not chemists, bronze is not an element. The Br on the periodic table is bromine, not bronze. And you can see that these were watched by quite large numbers of people. Then in the Large Hadron Collider sprung a leak of helium. So we tried to explain why there was helium in the Large Hadron Collider. And we made a video, or rather I made a video about the Nobel Prize in 2008, which was for the green fluorescent protein, in which I sat in front of the television, watched the announcement, and then immediately made the video. And this has become a tradition, so we've done it 4 years running. And in November, I met the Secretary General of the Swedish Academy of Sciences, who said that he was sure he had met me. And I said I was sure he hadn't. And about halfway through the conversation, he said that he now knew he had used our video to explain the chemistry of the Nobel Prize to the Swedish king, which I feel is success. And then we've done other videos, which by far our most successful has been Candles at Halloween, which was watched by nearly 250,000 people in 3 days. And this video consists of little more than me lighting a candle and blowing it out with a small amount of wolf noise in the background. And then we've done a whole series of other ones, tea chemistry for the Chinese New Year and snow chemistry, which has been aired more than once when there has been snow in the UK. And at 12 o'clock, we had 64,208 subscribers, which placed us at 2,149 in the YouTube list of subscribers, which is about 300 places above Chelsea Football Club. And so we've then been on trips abroad. So here I am at the GSI in Darmstadt, the institute where the elements Röntgenium number 111 was synthesized, and here I'm sitting in the control room wearing the same jacket talking about the chemistry. So I really began to learn a bit more. We've put on captions. All our main videos are now captioned in English, which is useful, first of all, because most of our viewers are not native speakers of English. They also help those who are, have hearing difficulties, but it's also useful in a classroom. If lots of people are watching different videos, they can watch it silent with the captions rather than having my voice and my colleagues playing as a sort of Tower of Babel. And we've also had quite a lot done in Spanish, and we've had 169 translated into Brazilian Portuguese. And once something has been translated, you can automatically, through YouTube, translate into another language. So this is an automatic translation of the video on cesium, but I'm not capable of telling whether this is a correct translation. So my Chinese colleagues can tell me afterwards whether it makes sense. And we have done some public shows. For those of you from outside Nottingham, this is the Broadway Cinema, which is the leading art cinema in the Midlands. I would like to say in the UK, but that's perhaps a bit much. And we did a performance where we made a video that was shown on the small screens, the one that people watch while they're queuing up to buy their tickets and so on. And then we did a live performance in May 2009. And I don't know if you've ever lectured in a cinema. It was the first time I had. And when you look at them, they are designed to burn really well. So trying to do chemistry lectures is dodgy. And here is my colleague Sam Tang demonstrating dry ice. And this is me. It's looking at myself really large on the screen. It's quite frightening, I suppose, unless you're a film star, seeing your face quite so big on the screen. And it feels a bit strange. So we've started. We went last year in May, Brady and I, to an exhibition which had been set up completely independent of us by a museum called in Rio de Janeiro, where they had used our periodic videos as the basis of an exhibit. And here the group who did it, and we were trying to make then our names out of elements. Martyn, there weren't enough letters, but Brady did quite well making his. And we've now started making videos about compounds as well as elements, and this was originally funded by EPSRC. It's now funded by Aldrich Chemicals, one of the largest chemical suppliers. And this includes our most watched video here, which was done particularly by my colleague Darren Walsh, who's sitting here, which at lunchtime today had just passed 600,000 views, 600,331. And this involves dunking a cheeseburger into concentrated sulfuric acid under the rather flimsy pretext that there is sulfuric acid in, in the hydrochloric acid. It's dunked into under the pretext that there is hydrochloric acid in your stomach, but not quite of that strength. And it ends up in an indescribably yuck mess, which the viewers like. And of course, talking about molecules gives me quite a good opportunity when I'm traveling to talk about molecules. So here's a picture of me talking about ozone on Bondi Beach. And I was totally unaware that these people were there. And of course, with all this traveling, made me think that an ideal place to try and show these videos would be on long-haul flights. There are people sitting there, and you can't pay much attention to the screens because every few minutes they say, fasten your seatbelts, or would you like some more drinks, or whatever. So I just feel it would be a really good place to show these videos. And also you could then nudge your neighbour and say, have you seen this one, and so on. But we don't yet have any good contacts with airlines. So if you know somebody who is senior in an airline, do let us know, and perhaps we can do that. So the physics department started a rival channel, or I should say complementary channel, called 60 Symbols. They don't have a periodic table in physics, so they made one up. And it is very successful. In a few days' time, they will overtake the number of subscribers that Periodic Videos has. They have made, I think, 160-something videos. We've made 386, which just demonstrates that physics is only half as interesting as chemistry. I appear on one or two of these videos, particularly Schrödinger's cat, which is rather fun, though my model was a mosquito rather than a cat. And so this really comes to the question of whether we're making any impact. And Brady and I wrote an article about a year ago for the quite upmarket journal called Nature Chemistry, in which we discussed this. How would you judge whether we're making an impact? And so you can look at the number of views, but the problem with that is you can't distinguish between a school teacher who's showing the film to a whole class of pupils, or some really sad individual who's sitting in a garret watching the same video over and over again. Brady class is me in the second class of this. And you can look at the number of subscribers, but the problem is that it's quite difficult to see how our subscriber numbers compare with other people, and how the number of people who unsubscribe, who they join the channel and then think it's boring and unsubscribe. We lose about 10% of our viewers subscribe and then unsubscribe, and you can't get this information for other people. So we decided, although it's not totally scientific, that the best thing to do is to look at the comments that people post on the videos. And so this is one that was posted on 26th of January that's very typical of the sort of comments we're getting, which says, I'm picking my GCSEs next week. You've contributed a lot into making me interested in choosing chemistry. Thanks. And we also get comments from really quite professional scientists. This message here was in response to our video when elements 114 and 116 were confirmed as having been discovered. And Paul Carroll, who was chair of the committee that had made this decision, sent an unsolicited email saying, I just watched your video on the new elements 114 and 16 and found it exceptionally well done, accurate, insightful, what a delight, which is quite heartwarming. And then, like David, who was lecturing before T, we have made a Wordle of the 100 most common words that are found in a whole number of comments. I can't remember. It was something like 200,000 comments. And you can see the word like is quite big, and really is quite big, and love and chemistry is reasonably big. And for reasons that are perhaps less obvious, there is hair comes in there. And so generally, it's quite positive. We can also look at photos and gifts and things that we've been sent. There's some outside, when you have the wine, you will see the collection of elements that fans have sent me. And I like this one. This is a guy called Eddie, who at the time of this photo was 11 in Arkansas. And his mother, Arkansas is in America, for those of you who haven't done geography. And his mother wrote to us and said that she couldn't think of what to get him for Christmas. He was a great fan. Would we send a signed photograph? So we sent it. And here is her photo of Eddie unwrapping the parcel. And here it is when he got it open. And assuming that his mother is being genuine with him, she couldn't really have faked such a photo. And then there's this photo, which I quite like. I gave a lecture in Sydney, and I came out of the lecture, and there was this schoolboy, Brandon, who rushed up to me and said he was really sorry he couldn't come to my lecture because he'd been at school, but he'd slipped out in his lunch hour just so he could come and see me and say how much he enjoyed the videos. And I was quite moved, which is why I'm making such a strange face. And so I think that these things are really quite encouraging. And this is our youngest viewer, who's an 18-month-old baby, or then was 18-month-old in Denmark. We put this picture on the video, and I said that I was rather disturbed by the gun. And there was a reply posted by the father saying there was no need to worry, it had been in the family a long time, which I'm not sure does. And then there are our own students, and this is Becky, who they're making me a birthday cake, and here's Radmila, who's in the audience, who's icing it, and they made me, a group of them, made me a whole periodic table of cupcakes, which was in the foyer here, and a large number of students, to be precise, 118, were fed with cakes, free cakes, 117 because I had one. And I particularly like this cake here with hair on it. So the previous birthday, I was given what was the world's smallest periodic table that was engraved on one of my hairs. You can see this is my hair. And on this hair here, which was engraved in the university's nano center, there is a periodic table, not a very good one, but you can just about read it. And you can even see, it even had the latest element at that stage, copernicium, on it, number 112. And so the question is, how do we know it's the smallest periodic table? Well, if you go out and buy your Guinness World Records, on page 166, you will see this, which if you blow it up, saying the smallest periodic table in the world, unfortunately with a picture of me. In my wildest nightmares, I could not have imagined being in the Guinness World Records, but you'll see. So this then really raises the question about why do the videos work? And from an educational point of view, they're really quite surprising. There have absolutely no educational objectives. We do not sit down and write learning objectives and so on. And there is no storyboard or script for any of our videos. And in fact, even those participating like me are not always sure what we're going to say before the camera starts. And when there are more than one person on the video, each person is filmed separately. So Dr. A does not know what Dr. B is going to say or has said. And there is absolutely no corporate message. We don't sit there saying, come to Nottingham, or whatever. And the most surprising thing of all is that there is absolutely no editorial control. When I make a video, the first time I see it is when it has been watched probably by 300 people on YouTube. And this has the advantage that we can operate really quickly. From having an idea to having the video there can be, I think our record has been about 3.5 hours when the element copernicium was named. And it works because there is trust between the scientists and the video journalist. So the other things that are unusual is that they're quite funny, the videos, but they're by and large trustworthy. Occasionally we make mistakes, but usually as soon as we notice them, we post a comment or something so it's clear. And the other thing is, if things go wrong, we still show them. If the wonderful experiment like cesium doesn't go off or whatever it is, we don't hide the fact. And we tackle sometimes really quite difficult subjects. I've made now 6 videos about people who are quite close to me who've died, and talking about feeling sad and showing our emotions, which I think those watching seem to appreciate. And it's also very helpful for me. And the other thing which is really important is our videos are made with professional quality cameras, and they're broadcast quality, but they look amateur, but they are very slickly and professionally cut. And the most important thing is because there is trust and partnership between the scientist and the journalist, which is very unusual, if not unique. And of course, the really important and key thing for the success is Brady Harron, who's shown here. And this is Brady and me, as you can see, in Sydney Harbour. And I think this photo also demonstrates our joint obsessive nature. To get here, we had both travelled about 24 hours on different flights for various reasons. And we both arrived in Sydney at about 6 o'clock in the morning. And by lunchtime, we had made 6 new videos. And here we are, we're actually at a school where one of the school teachers was a real fan, and it had a fantastic view of Sydney. And of course, here is the Wiggly Giggly, which had a trip to Australia as well. Obviously, much of the success is due to the team, and here are my colleagues. Debbie has just produced a baby, so sadly she can't be here. But without these people, the videos wouldn't be like they were. And I think last week we had a very nice comment posted on YouTube, which I think sums the whole thing up. It says, I'm sure many young people not only learned some science thanks to these videos, but also decided to start a career in science as a result. You, meaning all the team at the University of Nottingham, making videos in periodic videos, 60 symbols, etc., are making a great contribution to science. And I think this is a very nice summary, and I'm delighted that there's at least one of the stars of 60 symbols, Roger, who is sitting there. And we also have to thank the people who have provided money, and really quite small companies like Briggs, which is a local company in Burton-on-Trent, which makes brewing equipment, has produced some money, and also the Animax Charitable Foundation that is run by one of my former tutees who has made money in later life and feels that chemistry should be promoted. And we're very grateful to all these people. And finally, I would just like to thank my long-suffering wife, Janet, who has probably watched more videos than any other non-chemist, and sometimes has had to watch them more than once if I feel that she has not appreciated it sufficiently. So thank you very much indeed. And so so finally, since we're here to honour Ron Nyholm, I thought I would just show you the video that we made for him to celebrate this occasion. Today, I wanted to tell Brady about a prize that I'd won, named after an Australian chemist, Ron Nyholm. And he told me that it was Australia Day today, so it seems particularly appropriate. And Ron Nyholm is a chemist whose name is not terribly well known outside inorganic chemistry, but who is one of the great father figures of inorganic chemistry and also of chemical education. And the Royal Society of Chemistry has a medal in his name. One year it's awarded for inorganic chemistry and the next year for education, and so on, backwards and forwards. And I won it for education. So here's the medal, and you can see there's a picture of Ron Nyholm, and there's quite an impressive crest on the back of the Royal Society of Chemistry. And it's made of silver, and it has my name on it. What's really exciting for me is that I was awarded this for my contribution to chemical education, largely via YouTube. So first of all, I should thank everybody who's watching, because you contributed to my winning a prize, and I'm very grateful to you. But what is amazing about Ron Nyholm, who died in 1971, is that most of the things that I and my colleagues teach as inorganic chemistry here in Nottingham and across the world were pioneered by him. Not that he discovered them, but that he brought them together as being important points of inorganic chemistry. And in a few days' time, I have to give a lecture about Ron Nyholm and education, and I'm going to talk a bit about how he worked in arsenic chemistry, quite a nasty area of chemistry. I've never worked in arsenic. And he also worked very heavily on the structure of molecules, an area where many of you who are watching, if you've been studying chemistry at school, will have come across his work, was in predicting the shapes of molecules of the main group elements. He produced a theory together with a Canadian chemist called Ron Gillespie to explain these shapes. When I was a student, it was called the Nyholm-Gillespie theory. Now it has a rather less romantic name of VSEPR, valence shell electron pair repulsion. But the idea is that you count up the number of electrons or pairs of electrons in a molecule, and the number of pairs of electrons determines the shape of the molecule. If there are 4, it can be tetrahedral, like this one. Or if there's 6 of them, you have an octahedral molecule. This is my commando molecule. And if there are 5, you can get different shapes, but usually you get this one, which is called the trigonal bipyramid. And he also explained that if you have 4 atoms bonded round and 2 pairs of electrons, you get a square-shaped molecule with the electrons above and below. But the really exciting thing that Nyholm explained was actually the bond angles of molecules. And he explained that in a molecule like this one, this is sulfur tetrafluoride, 4 fluorines and a sulfur in the middle, yellow for sulfur. He explained that in this molecule, why these 2 here were pushed backwards by the presence of a pair of electrons here. It's quite funny, because of him, this molecule SF4, which is really quite an obscure molecule, has become really famous in structural inorganic chemistry. Ron Nyholm, if you read his obituary, was meant to be a fantastically warm character. Whenever he went into a room, the conversation all lit up, and he was really a great enthusiast. And one of the big disappointments of my life was that I never met him. And I very nearly met him. I was at a party in Cambridge in 1971, in December, when he was due to arrive. But en route to Cambridge, he had a terrible car crash. He drove into the back of another vehicle and was killed. And it was a real tragedy because he was only 54. Probably much of his best work was ahead of him, but he died. And I think it is a tribute to the excellence of his work that more than 40 years after this car crash, he's still remembered every year with one of the most prestigious medals of the Royal Society of Chemistry. I think it's really good for us today on Australia Day to think about the memory of Ron Nyholm, who really made inorganic chemistry the exciting subject that it is today. Thank you.